Let's look at a problem from the Chapter 8.1 homework. What is -1 to the n when n isn't an integer? Well, let's start with n being an integer, just to make life a little easy. What is -1 to the 0? Well, anything to the 0 is 1, at least in this chapter, so that's 1. And then the first question that the homework asks us about, what is -1 to the 0.5? Well, anything to the 0.5 you can think of as the square root of something. So what's the square root of -1? That's not a real number, but it is an imaginary number. That's I, the imaginary unit number. Engineers sometimes call it J, from what I've heard. Because they're already using I for current, I think. And then the homework asks, what's -1 to the 0.75? That one's harder to do in your head, but we can go check Wolfram Alpha or something. So if you just type -1 to the 0.75, it tells you the answer is -0.707-ish plus 0.707i. And it even says, here's a plot of it in the complex plane. So it's back behind the y-axis here, but still in the positive y values. So let's go plot that. So what it said, it was -0.707 plus 0.707i, and this is rounded a little bit. What it really is 1 over root 2 plus 1 over root 2i, and it said it's here in the complex plane. Now that we're thinking about the complex plane, where this is the imaginary axis and this is the real axis, let's go back and think about what was going on here. We got I, which we could also write as 0 real plus 1i. So that would be 0 on the real axis and 1 on the imaginary axis. What was this? This was 1, which you could say is 1 real plus 0i. And that would be over here on 1 with a y coordinate of 0. So here we are at n equals 0. Here we are at n equals 0.5. Here we are at n equals 0.75. What do you think is going to happen if we try -1 to the 1? Well, anything to the 1 is itself, so we get -1, which we could write as -1 plus no imaginary. And so that would be on the x-axis, the real axis, over here. So n equals 1. So it seems like from n equals 0 to n equals 1, we went around here. And this 1 over root 2, or 0.707, you might recognize that as a special trig value from sine and cosine. That means we're on the unit circle. So we kind of started here and went up around the unit circle to here, as n went from 0 to 1. What do you think will happen as we go from n equals 1 to 2? Well, n equals 2 will be -1 squared, which is 1 again. So by the time we get back over here, we'll be there. So we're kind of just going around and pretend that's a circle. Going around and around the unit circle as n increases. And most of the time the value is imaginary or complex, but for n equals 0, n equals 1, n equals 2, n equals 3, the value is purely real. Another good way to think of this is in 3 dimensions, of course. Let's say we have our axis like this, where this is the imaginary axis, this is the real axis, and this is n. What's happening when n is 0? We had a real value of 1. So notice without the imaginaries here, this is like x and this is y. So the way that Desmos would do a plot, for example. So when n was 0, we had a real value of 1. So we were up here. When n was 1, we had a real value of -1. So we were down here. And in between, we had positive values of the imaginary component. So we would have come out on this axis. So we would have come out like this, hit the plane of the real purely real numbers here, and then by the time we got to 2, we would have gone kind of back behind and then hit that and then come out again and hit the plane of the purely reals again at 3. So we're looping around and around. We're tracing a circle, but we're also moving to the right here. So what shape do you get if you trace a circle as you move to the right? You could call that a helix, or you could call that a slinky, right? So the homework question says something like, this is a good question to ask in the spring, and that's essentially what's going on here. We're tracing out the shape of a helix or the shape of a spring. So what we see if we plot this in some software, it only plots the real component, and so it plots a 1 there at n equals 0. At n equals 1, it plots a -1, then a +1 at n equals 2, and a -1 at n equals 3, just where this helix is piercing that vertical plane of just the pure reals. This means that graphing software has real trouble with graphing -1 to the n, because most of the time it's getting stuff with imaginary parts to it as well. Let's go take a look at what happens with Desmos. Okay, here we are. I've got f of x equals -1 to the x, and it might be hard to see even. There's little red dots here at y equals 1 and y equals -1, but they seem to have kind of an irregular spacing. Like out here they're regular, but then we kind of miss a few in here. But what points do we get? We get a point at 0, 1, and then we get another point at -1 at n equals 1, y equals -1, and then another one here at 2, 1, 3, -1, etc. But these other points, they really should have some real and some imaginary component. In some sense, they shouldn't even be plotted. I think maybe some round-off errors sneaking through. It's funny, you can't even really click on them and get anything. It's only the integer points where you can, where Desmos kind of recognizes, hey, this is purely a real number. It's interesting that sometimes that round-off error just doesn't happen the right way, and we get a missing point there. You might think, well, let me zoom in and see what's happening. And different things happen at different zoom levels, and sometimes you just get nothing. Not even the things we know should be real. So that's kind of interesting. Let's go back to the home axis, kind of -10 to 10. One way we can get around this in Desmos, but it's not perfect, would be to say g of x equals -1, and let's say we don't want to take fractional powers of x. We could say raise it to the round x, and that way if x is anywhere between -1/2 and +1/2, that will round to 0, and we get values of 1 because it's -1 to the 0. And then if x is between 1/2 and 1/2, x will round to 1, and then we'll get -1 to the 1. So that's one way to do it. Another way to do it is to say raise it to the floor of x. Floor just chops off any fractional part when it's positive. So like floor of 1.9 is still 1. Floor of 0.9 is 0. But then it gets tricky for negatives. Floor of -1 is the integer below floor of -0.1 is the integer below -0.1, which is -1. So it doesn't mush things towards 0 by chopping off the decimal. It moves it toward the integer below it. And if that's floor, then ceiling must be the opposite, right? Except we abbreviate that with ceil, like that. So that's how to get Desmos to do nice plots of -1 to the x or something like that. Another way to do it is to add a table and tell Desmos, here we can call this n, we'll call this f of n. Here you can tell Desmos exactly what n values to use, 0, 1, 2, 3, 4, 5, 6, etc. So there it doesn't have any problems with fractional n values because you typed in integers. And it also plots whatever's in the table, so then you can see the individual values.